For this location, we'll be heading deep into the top-end outback of Western Australia. We're going to be looking at the Bungle Bungle Range in the Purnululu National Park. This is not an area that I've been to as of yet, but I have done a puzzle of it, and it was probably the most difficult puzzle I've ever done. The Bungle Bungle Range consists of a plateau, gorges and valleys that stretch on for many kilometres, and on the southern and eastern edges are these incredibly striking dome structures called cone casts or beehives. In fact, these are some of the best cone casts in the world. Though you may not guess it from their appearance, the majority of these cone casts are sandstone, but there are some conglomerates around too. The rocks are roughly 360 million years old, which puts us in the Devonian period. Both the sandstone and conglomerates would have been formed from sediments that were deposited by rivers into a basin environment at the foot of mountains that existed here once upon a time. The conglomerates would have most likely been part of the alluvial fans, and the sandstone would have been part of the alluvial plains. Over time, these sediments would have been buried, lithified, and then uplift and erosion has exposed them on the surface again. The cone casts are formed because the sandstone has very little cement holding it together. This means this rock is very susceptible to being broken or the grains removed due to the actions of water, wind, plants, and animals. If you were to brush your hand across one of these domes, you would likely take an amount of quartz with you. So it's likely that water, wind, and other types of physical erosion has made its way through weaker areas of the sandstone, resulting in weathering and erosion. These weaker areas have led to the formation of these gorges, valleys, and cone casts. But what about these amazing coloured layers? How can it all be sandstone and not alternating layers of different sediments? Well, interestingly enough, if you were to crack open one of these domes, the appearance of the sandstone would probably be very similar to most sandstones you find around the world. The banded appearance is purely an external feature from the work of weathering and bacteria. The darker bands contain a degree of clay minerals which are able to hold water and prevent it easily moving through these layers. This has created an environment for cyanobacteria to exist along the outside of the rocks, giving the darker layers their colour. The lighter layers are more pure sandstone containing mostly quartz, so water is able to move through these layers with relative ease, making it unappealing to the cyanobacteria. The orange colour comes from iron and manganese that has been oxidized. Isn't that the most simplest explanation for a geological feature ever? But it still speaks to the forces at work in the past and present that have formed and shaped these amazing structures through time. And it also goes to show that even a simple sedimentary rock like sandstone can look pretty amazing in the right setting.